This video is on section 7.1 notes, interest. So we're going to be talking about a few different types of interest formulas. The first is simple interest. And before we get into that, it'll be helpful for us to have some vocabulary terms defined. So the first is interest itself. Interest is the money that one person, a borrower, pays to another person, a lender, to use the lender's money. The interest rate is the annual percentage that is earned for that interest amount. So it says the annual percentage of deposit that is earned while that deposit remains in an account. So that's the interest rate. The principal is the amount deposited into a bank account, often called the present value. And then the future value, or the future amount, is the amount that will be in an account sometime in the future when the earned interest is added to the principal. So there's a formula for computing simple interest, and they will always use that term, simple interest, when they want you to use this formula. So it's interest equals principal times rate times time, and that rate is the percentage, the interest percent in the problem, but you need to use a decimal number to plug in here. So if you had like this example as 6%, you wouldn't plug in 6, you would plug in 0.06 because that is 6% written as a decimal. All right, so let's look at this first example. It says if you deposit $600 into an account paying 6% annual interest, how much interest will the deposit earn in 4 years if the bank computes the interest using simple interest? So simple interest is our clue that we should be using this formula. So I have I equals P times R times T. So the interest amount is going to be the principal of 600 times 0.06 for the interest rate times 4 years for the time. So 600 times 0.06 times 4. And so the interest would be $144. Computing the future value using simple interest uses this formula. So you have the future value, or the future amount, is the principal multiplied by 1 plus the rate as a decimal times the time. So assume that you deposited $1,000 into an account that is paying 3% annual interest for 6 years. Use the simple interest formula to calculate the future value of this account. So they didn't just say calculate the simple interest. If they said just the simple interest, we would have used the previous formula. They said find the future value, or the future amount. And so that's why we're using this new formula. So A equals the principal, 1,000, times 1 plus the rate, 0.03, so 3% is 0.03, multiplied by the time, 6 years. And so I've got 1,000, 1 plus 0.03 times 6. So that would be $1,180 in the account. So $1,000, that's the principal amount in the account. $180 is the interest that was earned. All right, assume that you plan to save $2,500 to take a whitewater rafting trip on the Rio Grande River in New Mexico in 2 years. Your bank offers a certificate of deposit, CD, that pays 4% annual interest computed using simple interest. How much must you put in the CD now to have the necessary money in 2 years? So we want to calculate what the principal should be, what we should put in now to have the correct future value. So we're going to use this same formula, but we are solving for a different number. So we know that we want to have $2,500, but we don't know this value, how much we want to put in the account to start with. We know that our interest rate is 4%, so I'm going to have 0.04, and we know that our trip is going to be in 2 years. So that's going to be 2. So I can go ahead and calculate this. With order of operations, please excuse my dear Aunt Sally. We remember that the P tells us to do things inside of parentheses first, so it's all right for us to plug all these in. 1.08. All right, so 2,500 equals P times 1.08. And now I'm going to go ahead and solve for the principal value by undoing this multiplication. So I'm going to divide by 1.08, divide by 1.08. And so the principal value is 2,500 divided by 1.08, 2,314 and 81 cents. All right, so this is saying if you wanted to get to $2,500 and not have to really save the money actively, but only just get interest to earn that money, then this is how much money you'd have to start with in an account to get to $2,500 by earning interest alone. That's it. That's why you have to start with so much money. All right, the next formula that we're going to work with is compound interest. So compound interest is interest that is paid on the principal plus previously earned interest. So assume that you want to replace your sailboat with a larger one in 3 years. To save for a down payment for this purchase, you deposit $2,000 in a bank that pays 10% annual interest compounded annually. How much will be in the account at the end of 3 years? So they didn't say simple interest. They said annual interest, and they told you how often it was compounded. They said it was compounded annually, and they'll give you different time frames that things can be compounded, that the interest can be compounded. Maybe it would say quarterly or monthly or semi-annually or weekly. So in this case, it said annually, which means one time per year. So one time per year, you get an extra 10% added into your account from interest. So this is the 100%. You're keeping what's in your account plus the 10% that you're getting added to your account. And they wrote that as a decimal number. And so that's why it's 1.10. So $2,000 multiplied by 100%, keeping the amount of money we had before, adding 10% in interest, gives us $2,200 for the second year. So in the second year, we start with $2,200. And then in that year, we're also going to get the same amount of interest. We're going to keep 100% of the money, but we're also going to add 10% in interest the second year. And so 2,200 multiplied by 1.10 is $2,420. So $2,420 in the third year is going to multiply by 1 to keep 100% of the amount in the account, but also by 0.10 to add the additional 10% in interest. And so we're going to take this and multiply by 1.10, and we get $2,662 would be in the account at the end of that time. So what you'll notice is that for the first year, we had 2,000 and we multiplied by 1.1. For the second year, if we think about this giving us our resulting amount, we took that resulting amount and we multiplied it by 1.1 again. So what we really did is we took 2,000 and we had it multiplied by 1.1, and then we multiplied it by 1.1 again, which means we did 2,000 multiplied by 1.1 squared. So I'll show you 2,000 multiplied by 1.1 squared. That's where the 2,420 came from. Okay, and then we took this, which was 2,000 times 1.1 times 1.1. We took this and we multiplied it by 1.1 again for the third year. 2,000 times 1.1 times 1.1, and then we multiplied it by 1.1 again. And so we really had 2,000 times 1.1 to the third power. So if we wanted to calculate how much money would be in the account the fourth year, all we really have to do is write 2,000 times 1.1 to the fourth. And that's how much money would be in the account the fourth year. If we wanted to know how much money is in the account the 10th year, we could say 2,000 multiplied by 1.1 to the 10th. If we wanted to know how much money would be in the account in the 30th year, we could say 2,000 times 1.1 to the 30th. And then this is how much money would be in the account in the 30th year. So we have a formula here, and the formula that we have is that the future value is the principal multiplied by 1 plus the rate. This is where we get the 1.1 from. We had 100% plus 10% was 1.1 raised to t, and t is how much time has passed, how many years have passed. So we did a 3 for 3 years, a 2 for 2 years, or we did just parentheses, we did just the 1.1 for 1 year. So this is the formula that we could work with to do compound interest if we were just talking about compounding interest once per year. Now, typically when we talk about compound interest, they're not always compounding the interest annually, which means once per year. Sometimes it's quarterly, sometimes it's monthly, sometimes it's daily. And so instead of using this formula, we end up using this formula right here because this allows us to compound more often than once per year. So we have A is the future value, P is the principal value, R is still the rate, so the percentage rate, the annual interest rate written as a percentage. M is the number of times that it's compounded per year, so if this is monthly or daily or whatever. And then N is the number of compounding periods multiplied by the number of years. So if we had 12 times per year for 5 years, we would do 12 times 5. So let's go ahead and take that formula and let's use it on the next problem. So it says you've seen a home fitness center on sale for $3,500, and what really makes the deal attractive is that there's no money down and no payments due for 6 months. Realize that although you do not have to make any payments, the dealer is not loaning you the money for 6 months for free. You have borrowed $3,500, and in 6 months, your payments will be based on that fact. Assuming that your dealer is charging an annual interest rate of 12%, compounded monthly, what interest will accumulate on your purchase over the next 6 months? So 6 months is half of a year. Okay, so they're saying, what is the future value? A is what we want to know. If we borrowed $3,500, and we have 1 plus, our rate is 12%, so we're going to say 0.12. Compounded monthly. So there's a 12 here, so I'm going to write notes to myself. This is compounded monthly. And this was for 6 months or half of a year. So we're going to say compounded monthly 12 times for 0.5 years, for half of a year. 12 times 0.5 is 6. So this is what we're going to plug into our calculator to see how much we're going to accumulate on this over the next 6 months. So 3,500 times 1 plus 0.12 divided by 12 raised to the 12 times 0.5, which is 6. And the answer is $3,715.32. So $3,500 of that was for the original cost of the home fitness center. But then there's money beyond that that we're just paying in interest. So if I take away $3,500, then that means that $215.32 is the interest that I didn't have to pay for 6 months, but I'm definitely paying it. I'm just paying it after the 6 months have passed. Okay, now this formula is where students start to feel like this is getting a little bit complicated and they maybe don't like this formula as much. And so we have something that's really neat in our calculators called a TVM solver. And so we're going to use either graphing calculators to do these exact same problems, or we're going to use a TVM solver website. And if you have the digital copy of these notes, this right here is actually a link to the website, and it looks just like this. You can fill in the numbers just like this. Or if you look on Moodle, I will put the TVM solver as a link on Moodle as well. So you can get to it either way. It looks like this, and it's going to be very similar to what we're plugging in on our calculator. Okay, so let's go ahead and try the first problem with this solver. It says, upon the birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's college education. Assume that the account has an annual interest rate of 4.8% and that the compounding is done quarterly. Okay, so the nice thing is that the interest rate up here, you do not have to write it as a decimal. You can write it as the number that it has. So this is 4.8%. That's what we're going to plug in right here. And that the compounding is done quarterly. This means the number of payments per year or the number of compoundings per year, and you're always going to put the same number in both places. So there's 4 quarters in a dollar, there's 4 quarters in a year. Every 3 months would be a quarter of a year. So here I'm going to say compounded quarterly. I just want to make sure I understand my notes if I look back at this later and don't know why I chose the numbers I did. How much should the parent deposit now so that the child will have $60,000 at the age of 18? So at the age of 18, that means that the time that has passed is 18 years from now. So N is going to be the time multiplied by the number of compounding periods. So compounding periods multiplied by time. So we're going to say 18 multiplied by 4. You don't even have to do the math here. You can literally type 18 multiplied by 4. PV stands for present value, and so this is what we're going to be solving for. So I'm going to put a question mark here. PMT stands for payment, like monthly payments, and we are not going to be making any monthly payments into this account. FV stands for future value, and the future value is the $60,000. Okay, so this stands for future value. Okay, this stands for present value. Okay, so if you were using this link and you had these numbers plugged in, you wouldn't have put a question mark there. You would have just left this blank. And then when you were done, you would have clicked solve for PV, and then it would pop out the answer. Now, for those of us who have graphing calculators, we're going to hit the app button, and finance is the first one. And it says TVM solver, pretty easy to get to. And we're just going to type in these values. So 18 times 4, 4.8. I'm going to ignore PV. I'm going to come back to that one. 0, 60, 1,000, 4, and 4. Okay, and now I'm going to go back up to PV, and this is what I want to solve for. So I have all the same values plugged in that you can see right here. And right above the enter button is green solve. And over here I have a green button. So I'm going to hit the green button and then I'm going to press enter and it's going to solve that for me. And it gives it to me in negative values, meaning that's money that I'm going to have to pay right now. It's not money that's going to come to me. It's money that I'm going to have to pay right now. So negative 25, 418.76, and this means how much should a parent deposit now so that the child will have $60,000 at the age of 18. The parent should deposit $25,418.76, and if they deposit that amount of money now, then in 18 years that child will have $60,000 for college. All right, the next example says, Dee Dee has invested $8,500 in old Star Wars memorabilia, which is currently increasing in value at 6.5% per year. If this increase continues at the same rate, how many years will Dee Dee's investment double? Okay, so we have the interest amount is 6.5. We have the present amount is $8,500 and you've invested, so you have paid that money. So we're going to say negative $8,500. That's what we're going to start with. All right. We are not making monthly payments. Monthly payments are 0. The future value is going to be double of the $8,500. So 8,500 times 2, I want to double it. That's 17,000. That's what I want my future value to be. Okay. They didn't say anything about compounding interest at quarterly or monthly or anything like that. So I'm just going to assume annually. The interest is annual, increasing in value annually per year, actually. So that is annual. And then up here, it says in how many years. That's what we're trying to solve for. And so up here, this is our question mark. This is what we're trying to find. So if you were using the TVM solver on the website, you would have typed all these values in, and then you would go up here, you would have left this one blank, and you would click solve for n, and it would give you the value. I'm going to go ahead and do this on my calculator. So I'm going to hit the apps button and press enter for finance and enter for TVM solver. And here I'm going to ignore the 72 for now. I'm going to type in 6.5, negative 8,500, 0, 17,000, 1, and 1. And then the n is what I wanted to solve for. So I'm going to go back up here to the 72, and I'm going to hit green button, enter, to solve. And it gives me the answer, 11.006739904. So n is 11, and so it will take 11 years for this investment to double because this problem was written in terms of years. The rule of 72 says to estimate the doubling time of a quantity, divide 72 by the growth rate. For example, in this example, the annual growth rate was 6.5%. So the doubling time is roughly 72 divided by 6.5, which is 11.077 years or 11.0067 years. So pretty close. All right. Let's go ahead and try one more of these problems using the TVM solver. So this problem says Marquise is negotiating a new contract. In order to reduce current taxes, he has agreed to defer a $15 million bonus to be paid as $18 million 4 years from now. If his team invests the $15 million now, what is the minimum annual interest rate they need to earn to guarantee that the $18 million is available in 4 years? Assume that the annual interest rate is compounded monthly. So $15 million is what they are investing. So the present value is what is being paid currently. and that's 15 million. So I'm going to write it as a negative because it's being paid. 15 million. Make sure I get all my zeros in there. The future amount we want is 18 million. They want this money to accrue through interest. They are not going to make payments to make this happen. This is just through interest. The thing that we are trying to solve is how much interest we need to have to make this happen. So that's where our question mark is. The interest rate is compounded monthly. So this is 12, 12, monthly, monthly. And then they said that this was happening 4 years from now. So N is monthly for 4 years. So that's going to be 12 times 4. Okay, so if you were on the website, you're just going to go plug all these numbers in and click solve for I%. If you're using your calculator, then you can go and start plugging in these different values. 12 times 4. I'm going to leave the I from the previous problem. Negative 15 million. 0 in payment. 18 million compounded monthly. Okay, and now I'm going to go up here to where the percentage is, and I'm going to do alpha solve, and it's 4.57%. So they want their interest to be 4.57% interest. All right, now to use the TVM solver for you to do math problems using this formula, then what I should see is that on your notebook paper, if you were taking a test, that you would write down N, I, PV, PMT, FV, P/Y, C/Y, and write down the numbers that you were plugging into the TVM solver, and then write out, the answer that you got. So to show your work in a testing situation, this is showing your work, even though we didn't use the formula and we didn't calculate it ourselves. So using the TVM solver is totally fine. In a testing situation, it's totally fine to do on your MyMathLab assignments. But if we need to show our work, this is how we're going to show it. And you don't have to, fill in a box that looks just like this. You can write it on notebook paper, but make sure you have all of these values written down so that it's easy for me to tell exactly what you plugged into the TVM solver.